Om Sri Guru Basava Lingaya Namaha. In the last class, we had seen about measurement of temperature. Well, let us see general measurement of temperature in the next class, means in this class, where we shall be seeing the temperatures, measurement of temperatures in different scales, considering different type of parameters. Well, parameter means what? Generally, what happens when temperature is increased? Length of a wire increases. When temperature is increased, then volume of the gas increases. When temperature increases, then pressure of the gas also increases. And when temperature increases, then resistance of the conductor also increases. So, these parameters, these terms are called as parameters. What? Length, volume, then pressure, then resistance. These are called as parameters. Using these parameters, we can find the temperatures. Well, now, here we will be using one general formula for that. What? Let us say x is the parameter. Well, we will write down this one for reference over on the right side. So, it is general measurement of temperature. General measurement of temperature. And for this, we write down here on this side that formula, so as we can be used as a reference in all the cases. Well, what is been found that at any temperature T, the parameter can be written as xt, and that at 0 degree can be written as x0 into 1 plus some coefficient into temperature T. Now, this can be written as xt is equal to x0 plus x0 alpha t. That can be written as xt minus x0 equal to x0 alpha t. So, it is equation number 1. Now, let us say at this temperature T, xt is the parameter. If we write T is equal to 100 degrees Celsius, 100 degrees Celsius, in such a case this equation will become x100 minus x0 is equal to x0 alpha into 100. Equation number 2. If we now divide this equation by this equation, we get xt minus x0 divided by x100 minus x0 equal to x0 alpha t divided by x0 alpha into 100. Now, these two terms cancel. We get here t is equal to, this will be multiplied here, we get on formula xt minus x0 divided by x100 minus x0 into 100 degree Celsius. 100 degrees Celsius. So, we will be having one relation to be this. This is when we are expressing the temperature in degrees Celsius, we get it on in this manner. Suppose say that we want to measure temperature in Kelvin. Here base used is what? Triple point temperature of water. Well, what is triple point temperature? Generally what we will find that at one temperature that is equal to 0 degrees Celsius of temperature, water will be existing in 3 states. One is solid, liquid and gas. Well, example is when we open the freezer box of refrigerator. Freezer box means what? Where we will be finding that ice will be formed. That box when we open, as soon as it is opened, we will find that there fumes of gas will be coming out. Fumes of gas means what? That is actually water vapor is coming out. Then second, if we touch the ice formed in the freezer, then if we touch, we will find that on the hand, water will stick. And anyway, ice will be there. So means at one temperature, we will find that all the three things will be present: water, water vapor, and solid means ice. And that temperature is how much? It is equal to 0 degrees Celsius. And in terms of Kelvin, we know that it can be written as how much? 273.15 Kelvin. 273.15 Kelvin. This temperature we can write as triple point temperature of water, that is TR. TR. Now, here we will use a parameter that some temperature T equal to A into parameter X plus B. So, this relation will be giving us conversion of temperature, measurement of temperature in terms of Kelvin. Now, here A and B are constant, X is the parameter, T is the temperature. It is in Kelvin. Now, what has been found that if you go for absolute 0 Kelvin of temperature, that is absolute 0 temperature, what has been found at this temperature, T will become 0 as well as the parameter also becomes 0. Means if we take one wire and cool it to 0 degrees Celsius of temperature, its resistance will become 0. That is, resistance becomes 0 as well as temperature becomes 0. So now, if we use this data, that temperature is becoming 0, A, and the parameter also is becoming 0, and constant B. What you will find that we get the value of B equal to how much? 0. Value of B is equal to 0. Well, that can be substituted here. We get T equal to AX. Say it is equation number 1. Now, assume that this temperature is taken as equal to how much? 273.15, that is triple point temperature. 273.15 Kelvin is equal to, now A parameter can be written as it is X. X will be having some value where at this temperature. So we can write that one as XTR, say equation number 2. Now if we divide equation 1 by equation 2, we will be getting here T divided by 273.15 equal to AX divided by AXTR. So A and A cancels. We can write T is equal to X by XTR into 273.15. This will be in terms of what? Kelvin. So here, second, T equal to X by XTR into 273.15 Kelvin is the second relation we'll be using here. So anyway, it is not required for need purpose to remember all this derivation. If you remember only these two formulae will be sufficient. So well, now we will go for measurement scales. We have got many measuring scales. First is a Celsius scale or centigrade scale. Centigrade scale. Now, in this Celsius scale of centigrade scale, well, what we do, we will be having, here one mistake has occurred. We have got different measurement, different type of thermometers are present with us. So, types of thermometers, we have to learn first, types of thermometers. Well, in that types of thermometer, first, we have got liquid thermometer. Second one is gas thermometer. Second one is gas thermometer. Third one is platinum resistance thermometer or only resistance thermometer. Now next one is thermocouple thermometer. Then next one is pyrometer or radiation thermometer. Is also called as pyrometer. Well, that centigrade scale or Celsius scale we had already seen in the last topic, so that is not required. Now here to measure this one will be making use of these type of thermometers. Well, here first one is means in this this gas thermometer has got two types. One is constant volume gas thermometer, and second one is constant pressure gas thermometer. Well, now we'll try to find out temperature in this different types of thermometers. Well, first we'll go for liquid thermometer. Well, here the principle involved is what? If we take certain liquid in a container, if we heat that container, what happens? The level of liquid rises or its volume increases. So that is, the volume of a liquid will be directly proportional to the rise in temperature or change in temperature. Means as we go on heating this one by more and more amount, the volume of the liquid will go on increasing by more and more amount. So that is the principle of this particular thermometer. Now here it is A part. Now we will be using this one. So since you have seen that we have got generally two type of thermometer, one is mercury thermometer, clinical thermometer, and other one is alcohol thermometer. Well, here you know that in this thermometer on the lower side mercury will be present, and there will be a thin region or pipe type of hollow region will be present. When we heat it, what happens? The volume of this liquid, that is mercury, expands and its level rises. Now what is being found at that here area will be constant, but length will be changing. So in the place of x, what we read on? We read on L. So now if we take LT as temperature, if we take LT as length at a 0 degree Celsius of temperature, length of the mercury or liquid at 0 degree Celsius, and it is at T degree Celsius, LT at T degree Celsius, L0 is a length at 0 degree Celsius, and L100 as a length at 100 degree Celsius. So here our parameters are LT, L0 and L100. LT is a length at T degree Celsius, L0 is a length at T degree Celsius, L100. So this can be substituted in the place of this. So if we substitute, we can write on temperature T as LT minus L0 divided by L100 minus L0 into 100 degrees Celsius. Well, it is what? It is temperature when we are measuring in terms of degrees Celsius. Now, what has been found? Again here parameter x is nothing but length, and when we are measuring temperature in Kelvin scale, we can write on this as T is equal to L divided by LTR into 273.15 Kelvin. 273.15 Kelvin. It is second one where we want to measure the temperature in the Kelvin. Now, what will find that this length is nothing but the length at temperature T. And so we can write on here L is length at temperature T. Length at temperature T. Well, here this thermometer means liquid mercury thermometer can be used to measure temperatures ranging from minus 30 degrees Celsius to about 350 degrees Celsius. For less temperature, this device is not suitable. In some books you find that this temperature is given to be how much? It is given to be minus 50 degrees Celsius to 350 degrees Celsius. Well, but actually freezing point of mercury is minus 38.8 degrees Celsius. Below that it becomes solid. So that's why here lower temperature that can be measured is minus 30 degrees Celsius to 350 degrees Celsius. Now, suppose say this is mercury here. If we fill nitrogen gas at higher pressure, nitrogen gas at higher pressure, then what is been found that we can increase this level to 500 degrees Celsius, means minus 30 degrees Celsius to 500 degrees Celsius of temperature can be measured by filling nitrogen at high pressure over mercury. Now, it has been found that if we use your alcohol, then this temperature range can be decreased. It is about 180 degrees Celsius, minus 80 degrees Celsius of temperature can be measured. Higher one will be what? 300 degrees Celsius, 350 degrees Celsius. And if you use pentane here, then it is been, we can measure temperatures of about minus 200 degrees Celsius or here in the liquid thermometer. Well, now the second type of thermometer is the gas thermometer. Gas thermometer, in gas thermometer we have got two types. One is a constant volume gas thermometer, and second one is a constant pressure gas thermometer, and second one is a constant pressure gas thermometer. Now, here again principle is what? That if we take gas, heat it, then what will happen? If we keep volume constant, then pressure will increase. If we keep pressure constant, volume will increase. So because when we heat normally a gas, then there are two variables for gas, both volume and pressure changes. So now if we keep any one constant, another variable, then that can be used as one thermometer. So here, if we keep volume constant, then what will happen? Pressure will change. And now, what is the principle? That by increase in temperature, the pressure of gas also increases. That is, increase in pressure is directly proportional to increase in temperature is the principle of constant volume gas thermometer. And here for this principle is opposite of it. So we are keeping pressure constant. So what will happen? Volume will change. So with increase in temperature, keeping pressure constant, volume will be increasing. How? The change in volume is directly proportional to change in temperature. Now, here B part. To measure the temperature, we have got here this relation. Well, here pressure is the variable. Let us say P naught is the pressure at 0 degrees Celsius. Pg is pressure at T degrees Celsius, and P100 is the pressure at 100 degrees Celsius. Then that formula can be written as T equal to Pt minus P naught by P100 minus P naught into 100 degrees Celsius. Whereas the second one, in terms of the triple point of water, X is nothing but our variable is P. So we go on T is equal to P divided by PTR into 273.15 Kelvin. So now this P is nothing but pressure at T Kelvin. So that is nothing but like this PT pressure at T degrees Celsius. Now here likewise for this one we can write on that if V naught is the volume at 0 degrees Celsius, Vt is the volume at T degrees Celsius, and V100 is the volume at 100 degrees Celsius, then we get on T is equal to Vt minus V naught divided by V100 minus V naught into 100 degrees Celsius. So will be giving us this, will be able to find out temperature of the gas at this particular volume. Now same manner, if you want to write down this formula for absolute scale of temperature, then we go on T is equal to V divided by VTR into 273.15 Kelvin. 273.15 Kelvin. Now what has been found that the gas thermometers, if we use hydrogen gas, then we can find or we can measure temperatures from 200 degrees Celsius to 500 degrees Celsius using hydrogen gas, and using nitrogen gas we can find temperature from minus 200 degrees Celsius to about 1200 degrees Celsius. 1200 degrees Celsius. Well, now the third type of thermometer is resistance thermometer. Well, now resistance thermometer, the word resistance you are learnt in 10th or 9th in school. Well, you know Ohm's law states that the current flowing through a conductor is directly proportional to potential difference applied across the ends of the conductor. So you are read like this: current is proportional to potential difference. Now if we remove the proportionality sign, we get it on this as R into, if we remove the proportionality sign, we will be getting here constant in the denominator, that is V by R, and this formula can be written as V equal to I into R. So this term R is called as what? Resistance. Those who are from Kannada medium, for them I think this was, the word used for this was avarodhaka. Avarodhaka word was used. So now here we are using that only as the identity to measure temperature. Well, now here, well, what is the principle? If we take a wire, if we heat the wire, as the temperature go on increasing, what happens? resistance of the wire also go on increasing. So that is what is the principle of this particular device. So principle is what? Change in resistance is directly proportional to change in temperature, or increase in resistance of a conductor is directly proportional to increase in temperature. Now this principle is used here. Well, now the parameter here is what? In the place of x, we have to write down what? R. So that is why we can write down the temperature as, suppose not the temperature, first we will take the parameter. Suppose R0 is a parameter at 0 degrees Celsius, RT is a parameter at T degrees Celsius, and R100 is a parameter at 100 degrees Celsius. 100 degrees Celsius. Now the temperature T can be written using that relation as T equal to RT minus R0 divided by R100 minus R0 into 100 degree Celsius. Well, third one, we can write on the same formula in terms of Kelvin using this formula as T is equal to R divided by RTR into 273.15 Kelvin. 273.15 Kelvin. Now, see, if you remember only one thing, when we are asked about mercury, means liquid thermometer, we can write down as LT minus L0 by L100 minus L0 into 100 degrees Celsius. That in case of triple point, L divided by LTR, and we will be getting that formula. For constant pressure, we get on Vt minus V0 by V100 minus V0, and here V by VTR. For constant volume, we get on Pt minus P0 by P100 minus P0, and here P by PTR can be written. And resistance RT minus R0 by R100 minus R0, and here R by RTR can be written. So that way we can go to different scale using only one formula, means that two formula. Well, now this thermometer can be used to measure temperature from minus 272 degrees Celsius to about 2000 degrees Celsius. So we will find that in some book this one number is given as 1200 degrees Celsius. So minus 272 degrees Celsius to 1200 or 2000 degrees Celsius of temperature can be measured. Now based on this formula we shall see some numericals. Well, excuse me, that one was there. Celsius scale we had seen in the last class, so by mistake I was writing that. Well, now here there is a problem. What? A constant volume gas thermometer. Which thermometer? Constant volume gas thermometer is showing pressure reading of 50 centimeter and 90 centimeter of mercury at 0 degree and 100 degree. It means it is a reading of pressure at 0 degree Celsius. So we can write that one as P0. P0 equal to 50 and P100 equal to 90. Well, we will write over here P0 equal to 50 centimeter and P100 as 90 centimeter. 90 centimeter. But now again, what is asked? What is the temperature on gas scale when the pressure reading is 60 centimeter? Pressure reading is how much? 60. And that temperature is how much is asked? So we can run this one as PT is equal to 60 centimeter. T temperature is asked. I think you can identify from this relation. Well, we are writing general thing. So, general formula is this. In the place of x, what we are doing down here? T naught. So, solution will be what? T is equal to Pt minus P naught divided by P100 minus P naught into 100 degree Celsius. PT is what? 60 minus 50 divided by 90 minus 50 into 100 degree Celsius. This will become 10 divided by 40 into 100 degree Celsius. This will go 425 jar. So we get here 25 degrees Celsius as a temperature. Now, let us go for next one here. It is a platinum resistance thermometer. Question of platinum resistance thermometer. The resistances corresponding to lower and upper. Lower means what? 0. Upper means what? 100. Are well, in a platinum resistance thermometer are 3.50 and 3.65. So means resistance at 0 degree Celsius is so much. Resistance at 100 degree Celsius is 3.65. So we will write down here given resistance at 0 is 3.5 ohm. Resistance at 100 degree is 3.65 ohm. 3.65 ohm. Well, what is asked? What would be the resistance at a temperature? What would be the resistance at a temperature equal to freezing point of mercury? Freezing point of mercury is given as minus 37 degrees Celsius. So temperature is given there minus 37 degrees Celsius. At that, what is the resistance is asked. Means RT is how much? Now, here in the place of x, what we have to write on? R we have to write on. So we get on T is equal to RT minus R naught divided by R100 minus R naught into 100 degrees Celsius. 100 degrees Celsius. T is how much? Minus 37 equal to RT is asked here minus R naught is 3.5 divided by R100 is 3.65 minus 3.5. 3.5. This will become minus 37 equal to RT minus 3.5 divided by 0.15. 0.15. Now we multiply the two. 15 7 ja 105. 105. 5. 10 will be carry here. 15 3 ja 45. 45 into 10. 55. 55. So this will become 1537 means 5.55 equal to, well, excuse me, here into 100 should be there, forgotten that, 100, so this will become divided by 100 equal to RT minus 3.5. Now this can be written as 0.0555 equal to RT minus 3.5. Now if we take this one here, minus sign is there, equal to 3.5 minus 0.0555 equal to RT. So RT equal to, now what will happen? Last one will be 5, then 1, 2, 3, 4 will be obtained 0.3 ohm. So this can be written as RT equal to 3.44 ohm. If we go for significant figure, depending upon what is the option given, we can choose that one, whether this is there or this is there. But now coming to the next question. Next question. given the resistance of a platinum resistance thermometer is found to be 11 ohm when dipped in triple point cell. Triple point cell means the cell in which IC is present. So triple point means it is based on this type of question. So here given that value of x equal to 11, value of xtr equal to 11 ohm. Why? It is the value of resistance at triple point of water. So as it is value at this, we have to take xtr. When it is dipped in a bath, bath means water bath, a water containing container containing water at higher temperature, the resistance is found to be 28.887 ohm. Means it is general thing, general one, x value. So, well, excuse me, here it is resistance, so we have to write down as R. So, RTR for first one, for this one, R value is 28.887 ohm is mentioned. Then what is asked? Find the temperature of the bath in degrees Celsius. We will be getting answer first in Kelvin. That one has to be converted to a degree Celsius. So we are asked to find out capital T in degree Celsius. We will use this relation in the place of x. What we are doing on R. Only that is the difference, and we can write on this as R divided by RTR into 273.15. Now this will become R equal to, T is equal to R is 28.887 by 11 into 273.15. This can be cut. 11 1 ja 11, 11 2 ja 22 point, 11 6 ja 66, then 2 is left, 11 2 ja and 11 6 ja. Now here we have to multiply the two, 273.15, 2.626, well 6 5 ja 30, 6 1 ja 639, 6 3 ja 18, 6 7 ja 42, 43, 4, 6 2 ja 12, 16. Then 2 5 ja 30, 2 5 ja 10, 2 1 ja 2 1 3, actually 15 2 ja 30, 2 3 ja 6, 2 7 ja 14, 1, 2 and 2 2 ja 4 1 5. This number are repeated. So in the third place we can write on this number 0 9 8 3 6 1, and in the next place we can write on this number, that same is repeated. So 0 3 6 4 5, and add this 0 9 1 1 10 19 1 1 11 12 12 10 22 2 2 6 plus 3 9 10 15 17 7 1 11 7. Where to put the decimal point? 3 digit plus 2 digit means 5 digit should be left from the right side. So the decimal point will come here. It will become T is equal to 717.29190. Will leave it because here after the 2 digit only decimal point is present. So this answer will be in terms of Kelvin, but answer asked is not this. They asked the temperature in degree Celsius. We can run that one as 717.29 minus 273.15. Then this answer will be in terms of what? Degree Celsius. So it can be written as T equal to 9 minus 5 is 4, 2 minus 1, 1, 5, 7 minus 3, 4, 11 minus 7, again 4, 6 minus 2, 4. So it is what? 444.14 degree Celsius. Well, so generally students will be getting confused in this question. Why? Answer asked is in degree Celsius, so in the place of applying this formula, they apply this formula and answer obtained will be wrong. So be careful in doing this question. Their triple point is mentioned, so that's why we have to use this formula. Well, now coming to the next one. Next one. Well, here given is the pressure of a gas filled in the bulb of a bulb at constant volume gas thermometer at 0 degree and at 0 degree and 100 degree Celsius are so much. So constant volume is there, reading of what? Pressure is there. So we run P 0 is equal to so much, P 100 equal to so much. So P 0 equal to 28.6 centimeter and P 100 is equal to 36.6 centimeter. Well, actually we can convert the pressure using the formula rho GH, but it is not required. We can take it directly. Well, then the temperature of the bulb at which pressure will be 35 centimeter of mercury is given. So PT is given to be equal to 35. Temperature is asked, means what? T is asked. But again, this thing can be solved using the formula PT minus P naught divided by P100 minus P naught into 100 degree Celsius. So your answers are given in terms of Celsius. So this will be a clear thing. Now T is equal to PT is 35 minus P naught is 28.6 divided by P100 is 36.6 minus 28.6 into 100. Now this will become 35. So 4 here, 4 minus 8, 6 divided by, here 6 minus 6, 0, then 16 minus 8 is 8 into 100, we get it. Remove, well, here, let this be as it is, 8 1 ja 8, 8 ja 64, so this will be obtained as 80 degrees Celsius. So temperature obtained will be 80 degrees Celsius. So answer is this 80 degrees Celsius. 80 degrees Celsius. Now there is a slightly different type of question is there. What? A Fahrenheit thermometer reads 113 degree Fahrenheit while a faulty Celsius thermometer reads 44 degrees Celsius. Well, it is based on the formula we have used earlier. So since it is little typical, we are considering here a Fahrenheit thermometer reads 113 degrees Celsius while faulty Celsius thermometer is reading 44. So temperature in Fahrenheit is given to be 113 degree Fahrenheit. 113 degree Fahrenheit. And temperature in Kelvin is given to be equal to 44 degrees Celsius. 44 degrees Celsius. Well, the correction to be applied to the Celsius thermometer is, well, what is the meaning of that? Actually, this reading is wrong. It is a faulty thermometer. So what we have to do? We have to first find the temperature in Celsius. Then find the difference in this, we'll write down this as T dash. And first we will find out the value of Tc and then find the difference that Tc minus Tc dash will be the correction that has to be applied. Now we know Tc divided by 5 is equal to Tf minus 32 divided by 9 is the relation we have got. So Tc is equal to, we can write on 5 by 9 into Tf minus 32. Tf minus 32, Tc is equal to 5 by 9 into 113 minus 32. Now this can be written as 5 by 9 into, if we subtract, we get here 1 and 8. 11 minus 3 is 8, 81. 9 1 ja, 9 9 ja cuts, T is equal to how much? 45 degrees Celsius. Well, actually here, what is the thing? We should get in that scale 45 degrees Celsius. But faulty scale is measuring 44. So what is the correction applied? Correction is equal to Tc minus Tc dash, 45 minus 44, how much? 1 degree Celsius. This answer is given in plus or minus, so we can choose here second as option, plus 1 degree Celsius, 44 degrees the reading. So if you add 1 to it, then what will happen? The thermometer of Celsius scale becomes a correct thermometer. Right? Well, now today here we stop. Tomorrow we shall see about the next two type of thermometers and proceed. Thank you.